Okay, I'm going to add a podcast here on the ocean's Twilight Zone, which is also known as the Mesopelagic Zone, which is the region between about 100 meters down to about a kilometer, where the top part has some light, maybe about 1 or 2% of the light that's coming at the surface is making it down to that depth, depending on other things like how much phytoplankton there is at the surface, which will shade and prevent more light from coming in, and plays a lot of role in biological production in the regions where nutrients are available. And at the bottom of the mesopelagic zone or the twilight zone, you basically have no light. So as you may know, ocean gets divided into a pelagic zone, which is at the top, mesopelagic zone in the middle, bathypelagic zone, and then sometimes hadal zone, which is at the very dark bottom. And also it's divided into euphotic zone, where there is enough light for photosynthesis, dysphotic zone, where there is this diffuse light like the twilight zone, and aphotic zone, where there is no light at all. And most of the living things there have their own chemoluminescence or biological ways of producing light to attract predators, to attract prey, to scare away predators, and so on and so forth. Okay, so global ocean does play a big role and is being considered more and more as a place where carbon dioxide removal can be done. So it's called ocean CDR, carbon dioxide removal, which was a no-no before, but now the National Academy of Sciences of the US has put out a special report on ocean CDR, which I will make a couple of podcasts out of elsewhere. So this is the various ways in which the ocean CDR is envisioned, with nutrient fertilization like iron fertilization, seaweed farming and sinking seaweeds, alkalinity enhancement. So in my carbon cycle course, you will find a lot of these details as well. Here I'm just using them to set up the scene for the mesopelagic zone and twilight zone, electrochemical CO2 scrubbing, ecosystem restoration, and so on and so forth. So here is a simple picture of its sunlit zone down to about 100 meters, twilight zone with some light at the top and basically disappearing light at the bottom, and the so-called midnight zone or the aphotic zone. So the twilight zone tends to occupy most of the ocean, and some places, especially around the islands, the exclusive economic zones, also tend to have some of the twilight zones. And Woods Hole is basically now arguing that we don't know, we don't know much about the twilight zone, but it is also now argued that it has an important role to play in climate change in terms of the amount of carbon it passes through this zone. So there have been attempts to estimate these things. So you have here exchanges from the euphotic zone into the twilight zone, various compartments. I won't read the numbers. These are estimates made by one study from 2014 that was published here in terms of carbon movement in the oceanic twilight zone. So you have compartments like the particulate organic carbon, dissolved organic carbon. There are detritivores, carnivores, suspended particulate organic carbon, which is light enough and buoyant enough that it stays there, which means it's a carbon pool. So it depends on how long it can stay there. Attached prokaryotes and prokaryote consumers, free-living prokaryotes and prokaryote consumers. So in general, whatever drops out of this zone tends to stay in the ocean for very long times, and may even become part of the sediment and get converted over time, geologic timescales, through metamorphosis into limestone and so on and so forth. Okay, so obviously it has a large role to play, and we don't have an incredibly good sense of just how much biomass there is, but it's estimated that it is a significant amount of biomass that's present there. So the biological pump and the solubility pump by which the ocean cycles inorganic and organic carbon are working through the twilight zone. So solubility pump is basically where you have upwelling, advection, and mixing of carbon in the vertical and horizontal. So you have CO2 coming from the atmosphere into the ocean, either via photosynthesis or gas exchanges into the sunlit zone, and there is circulation which can, like the thermohaline circulation that we talked about, which can take it down and keep it there for thousands of years, as we said. All of that has to go through the twilight zone, and so midnight zone here can stay for 1,000 years and then be brought up through solubility pump mixing and advection. And near the surface, of course, you have turbulent exchanges, upwelling, and much shorter time scales, like 10 years, whereas in the twilight zone, the residence time can be over 100 years. There is also the biological carbon pump, of course, where there is photosynthesis in the sunlit zone, and the herbivores and so on with zooplankton eat on that, and they produce detritus and sinking organic carbon, which is consumed in the twilight zone by microbes. Again, time scales of 10 years to 100 years to 1,000 years. And you can see that there is a lot of fish that feed in the twilight, in the sunlit zone, especially the visual predators like some of the tuna. But there are also big-eyed tuna and other whales and so on, which have special mechanisms by which they can dive very deep, because remember that the pressure increases tremendously, 1 atmosphere for every 10-meter depth change. So they have to have enough lung capacity and ways to collapse the lungs and keep the air and circulate the oxygen and so on to dive deep and come back up. So there is lots of migration happening as well. So the solubility pump and carbon pump have a gravitational part where hydrocarbons and biological material can drop by gravity. There is mixing, which can bring down or bring down the organic matter, bring up the preformed nutrients, which are conversions from organic matter back into nutrients, which have to go back to the euphoric zone to supply photosynthesis again, and lots of it gets exported out to the bottom. So this is just a microscopic image of marine snow, which consists of various things, and this is a pellet that was caught by Woods Hole. So this has here things like theropod shells, radiolarians, diatoms, and so on. So this general white material that drops through the twilight zone is known as marine snow, which supports a lot of life, and of course which is a large part of the carbon export as well. Looking at it another way here, so CO2 is exchanged, photosynthesis happens, grazing happens by zooplankton, then predators eat those, so aggregates form and sink out in the twilight zone. A lot of things get consumed, fecal pellets and so on, and the sinking remains of various marine organisms as well. And there is a whole food chain that exists in the vertical as well as horizontal. So compared to land, for example, the primary production in the land and the ocean can be similar, but in the ocean the secondary, tertiary, and quaternary production can be much higher because of this rich layer of consumption along the way. So here is the elongated bristlemouth and a glass jellyfish that were also photographed by Woods Hole in the twilight zone, and here you have various migrating contributions to the carbon cycle and biological pump. So feeding on the surface plankton, migrating animals, and non-migrating animals that remain at various levels and just wait for food to come down or rely on other animals that migrate up and down to catch food. So there has been also ideas by Bill Dewar, for example, that part of this migration is also moving heat up and down, and that would be important for the conversion of heavy bottom waters that we talked about back towards lighter surface waters, but that has to be confirmed as to whether marine organisms evolved to modulate their environment constantly, or they evaluated to use the environment that exists. Okay, so different philosophies there, but some estimates were made by Bill Dewar about how much heat energy is produced by marine biomass. Okay, Woodsole provides some infographics as to what the mesopelagic does. So 2 to 6 billion tons is the amount that the Twilight Zone helps in terms of carbon, moving carbon annually, or storing carbon annually. So that's up to 6 times the carbon emitted by all the cars worldwide. And without the mesopelagic zone or the Twilight Zone, Earth would be warmer by 6 to 11 degree Fahrenheit warmer, and that prevents $300 to $900 billion in economic loss each year, just to give you a sense of proportion of the role of carbon that's being stored by the Twilight Zone. How does the ocean Twilight Zone help feed humans and marine life? Twilight Zone could be harvested to produce nutritional supplements, to feed farmed fish. So a lot of the zooplankton that live in the mesopelagic zone are actually food for many of the upper level fish that migrate up and down. So the Twilight Zone plays a role that way to feed, but you can also use that to feed farmed fish as a supplement to exploiting fish unsustainably. Okay, to put seafood on your table. Okay, how does the ocean Twilight Zone support a healthy ocean? Twilight Zone may contain 10 times more fish than the rest of the ocean. May contain, because we still have a lot of data to be gathered. Many of these Twilight Zone creatures migrate to the surface each night, so they get away from predators during the day and come down into darker regions so they won't be seen. During the evening they go up to feed, so they migrate, and it is argued that a lot of carbon is moved in this way as well during migration. Animals at the surface feed on the Twilight Zone animals, so obviously the Twilight Zone produces feed fish or forage fish for a lot of the upper level predators. Human curiosity of the Twilight Zone encourages greater stewardship of our ocean, generally arguing. Many people rely on surface fisheries to survive, but obviously surface fisheries itself depends a lot on the Twilight Zone fish for their forage. So I thought this would be appropriate to put a brief podcast here in the role of the ocean in climate change, to give you some sense of how the Twilight Zone plays a role. We of course mentioned ocean's uptake of carbon dioxide, greenhouse gases, and anthropogenic CO2 invading the ocean and so on. So this is a slightly different perspective on how the solubility pump and biological pump working through the Twilight Zone are also playing a substantial role in moderating global warming. Okay, so let me leave it there.